Thank you very much. I'm very happy to be here today. Thank you everyone for coming and being here already this early in the morning. I hope you had a good night. I hope you are ready for today. And well, about myself, I'm a system engineer at Delivery Hero. I've been working for the last 4 years, 4 years, improving the capacity, performance, and resilience of our cloud infrastructure. You may know Delivery Hero by some of its brand names like Foodpanda, Foodora, eFood, and many others that we have around the world. We are operating in over 50 countries worldwide. And today I will focus on how we grew our Kubernetes infrastructure in order to support the business growth that we have been facing for the past few years. We started with Kubernetes a few years ago, and since then, we have invested a lot into this technology. Most of our services are running in Kubernetes, and since then, we have seen a major improvement in scalability and availability of the services. Of course, implementing Kubernetes wasn't easy, and after a few pitfalls, especially at the beginning, and years of experience, we actually managed to get a robust and well-standardized in the organization implementation. One of the great things at Delivery Hero is that since we have so many tech teams running in Kubernetes, we have a lot of experience and expertise inside the company, which help us grow together and it help us to prevent issues from happening in all the parts of the organization. Somebody makes a mistake, somebody learns something new or do some improvements, and it's shared across the entire organization for the benefit of all of us. As many others, when we adopted Kubernetes, we decided to do with a regional cluster approach. So one single large cluster will provide our services for multiple countries in the same geographical location. This, at the time we started with Kubernetes, was convenient because you have a few advantages I'm going to mention now, and also because it's more simple to manage in your deployments and clusters lifecycle when you're taking such approach. And for us, at the beginning of our journey, it made us feel safer to go with this. Some of the advantages when using this approach is that you have a better control over the deployment's lifecycle. It's much easier to track what version you are running of a particular service in every of the clusters, as you have minor number of clusters available. Simple to monitor, or relatively simple to monitor and visualize, and much quicker Kubernetes upgrades. However, as we started to grow the business and the bigger the numbers we had, we started to see a few inconveniences in this approach. Like, for example, it will be more likely, the more pods we run in our clusters, the more likely will be to hit a race condition in the contract table that will cause DNS requests to timeout. This wasn't very much happening, but of course, it started to grow as the number of DNS requests grew as well, and it became a bit more noticeable. Apart from that, when you're running on AWS, you have a maximum number of DNS requests that your network interface is able to process. After that limit is crossed, then AWS will start throttling your request. And then it means as the more your cluster grows, the more DNS pods or pods for the DNS service you are going to need to run in your cluster. Then the bigger the scale, the more your API, your Kubernetes API suffers. And when you're running on managed services like EKS or GKE, you don't control the master nodes, nor the control plane. In some cases, we experienced that in EKS, our Kubernetes API started to throttle requests, and that was impacting us in when scaling the cluster, and also when consuming the Kubernetes API. Of course, after contacting the AWS support and reaching to the EKS team, they're always able to increase the size of the master node and eventually satisfy all the load that you're having. But until that happens, you need to contact AWS, and there's going to have a bit of time where your services are going to be affected, especially if they are consuming the Kubernetes API, as some of ours do. You also have bigger nodes. Usually you will need bigger nodes as the larger the Kubernetes become and the more traffic you process. And that requires, well, that brings all the issues where, for example, as we know, the more containers you're running on a node, the more overwhelming you're putting the node, and more your not DNF, I'm sorry, the more your Kubernetes components are going to suffer in the node, and more likely to face all the issues. Increased blast radius. Of course, if you have an issue, an incident, you're going to affect many users across different countries and not just a particular country where you might have been affected only, because it's a minor incident, most likely related to one single group of users that in the end propagates to the rest of the tenants. And of course, many other drawbacks that I'm not going to mention at the moment, but of course, the bigger the cluster, the more issues you actually start facing. So for us to mitigate all of these problems and find alternatives, we decided to go multi-cluster. So for us, as a solution to all these disadvantages, and in order to provide more resilient, reliable services, we decided to split all our infrastructure per country into their own isolated infrastructure. So every country will have its own VPC, its own Kubernetes clusters, data layer, and every other dependency inside its own VPC. Apart from that, advantages, well, we will have a smaller blast radius, as an incident will only cause issues to a reduced group of users, less likely to hit DNS timeouts, as there will be less DNS requests happening per cluster at that time, less pressure on the Kubernetes API, reduce issues with IP tables when you have thousands of rules to be applied and updated constantly, more gradual scaling events, as not many countries will be growing the traffic simultaneously. You will also have a better scaling behavior in your clusters. You can customize resource allocation per country. So let's say you have a country where you are running a massive marketing campaign, and you want that country to, for a particular holiday or anything else, to have a bit more of resources allocated just for that time. And you also have some other benefits, like more granular access and so on. And that's why we decided to take this approach. But of course, taking this approach will bring other difficulties, like how to manage multiple clusters together, how to put the right visibility within our monitoring tools to provide clear visibility and clear alerting about all what is happening in that many clusters, and so on. But in any case, overcoming these new problems will be a benefit, as we will see a much better behavior in our services, and we will provide a much better experience to our customers. So we decided to divide this in two different phases. The first phase will bring the biggest changes and will already provide a huge improvement in reliability and availability of our services. So for the first phase, new isolated infrastructure will be deployed, and here, and this will bring already a lot of benefit to split the traffic that we're currently serving from one single cluster. And then, as a second phase that I will mention later, we will improve the uptime and availability of our services, and it will be more like a reinforcement of it, a reinforcement of this uptime and availability. So for the this first phase required a complete migration of the data layer, of our services, and of course it was a bit sensitive task. So for that, before proceeding with such task, we had to make sure that certain requirements were met, like our deployment process was ready to deploy in multiple clusters together, in multiple VPCs and places. And we also needed to have the monitoring tools updated so we could see all what is happening in the whole environment, and also in particular clusters and meta clusters together. So after that first step after this first phase is done and we succeeded with it, we decided to go with the second phase, which is to reinforce the uptime and availability of the service. So in this second phase, we will deploy multiple Kubernetes clusters in each of the countries that will be running all our services together at the same time. So with this, we can distribute the traffic that is coming to us in every single country across all the available replicas. And also it brings us the possibility to rebalance the traffic, like remove one of these replicas if it's having any issue, and rebalance all the traffic within the remaining replicas. Um, so, in order to achieve this status and provide this boost of availability for our services, we needed to, first of all, get some requirements very clear. First of all is that every group of clusters will be called a meta cluster. So for us to have a better reference on what is an issue, an incident occurring, or what kind of problem we are facing, we need to, first of all, understand if it's one replica in the cluster, and a cluster as a replica, or a group of clusters as a meta cluster. Every cluster in the meta cluster will run all our services within the same version, with the same version, and clusters will not talk to each other to improve fault tolerance. And in a meta cluster, traffic will be equally distributed across all healthy clusters. The goal was very clear. We wanted our CDN to send a request to us with a simple DNS load balancing, so all the traffic will be split across all the available replicas. And if in any case, any cluster started to throw errors or experience any kind of issues, we will be able to remove that cluster from the pool and keep serving our customers without any kind of service disruption, while we can investigate and mitigate any problem within the affected cluster. So this is an example of how at Delivery Hero we commit to our customers into always providing a great customer experience. And that's everything I wanted to share with you today. Thank you.